Okay, today we're going to talk about point slope form. So up until now, we've pretty much focused on the slope intercept form. And hopefully we realized it got that name slope intercept because we can see what the slope is and what the y-intercept is when we look at the equation. So now we're going on to point slope form, and we should be able to see a point that lies on the line and the slope. That's where that gets its name from. So there's three common ways to write linear equations. So far we've covered slope intercept form. Today we're going to start covering point slope form. And then after we're done with point slope, which won't be today, it'll be another day, we're going to talk about standard form. Okay. So today we'll focus on point slope form for writing a linear equation. It is called the point slope form because the slope, which is, still m, and a coordinate point from the line can be used to write the equation. So this gives us another avenue. And to do slope intercept form, we usually needed both the slope and the y-intercept. And this kind of takes us one step before that, where maybe we know the slope and we know one point, but we haven't yet found the y-intercept. So it kind of is another way to avoid doing the B method for finding the y-intercept, but we're going to still find out how we can wind up back at slope-intercept from point slope. So what does this formula look like? We know that slope-intercept form looks like y equals mx plus b. Hopefully we've imprinted that on our brain already. And so now we're going to talk about the point slope formula, which is y minus y sub 1 equals m times the difference of x minus x sub 1. And again, when we have subscripts like this, there's no mathematical computation involved. That's an indicator. So if you can guess, we only need one point to write point slope. So this x1 and this y1 are going to be from a point that we know lies on the line. And of course, m is slope, sometimes called rise over run or constant rate of change. So y1 is the y-coordinate from a point on the line. I'm going to go ahead and shoot this out. And we should know is the slope of the line. And x1 is the x-coordinate from a point on the line. And of course, this x1 and this y1, they need to come from the same point. We can't say, okay, what if we have more than one point? We're going to pull an x from here and a y from there. They need to be from the same ordered pair. So what does this look like? So say we're given 2 points, 4, 5, and -6, -15. And we're asked to write an equation in point slope form. So one of the things that should be in our toolbox at this point is how to find slope given 2 points. And that's our slope formula. y2 minus y1 over x2 minus x1. Now you might think to yourself, well, is what I name x1 and y1 in the slope formula have to be the same as x1 and y1 in the point slope? And not necessarily, because those are just kind of like indicators, placements to make sure things go in the right order. So we can have, say if we're given 3 points from the same line, we could choose 2 points and use them in the slope formula. We can use the third point in point slope. It doesn't really matter. Okay, so write an equation in point slope form. So the first thing we need to do is we need to determine what the slope is. So I'm going to actually insert, I'm just going to Bring this down here. So we should know that m equals, and I'm just going to put 5 minus negative 15 over 4 minus negative 6. Underline that. And we should know, well, 5 and double negatives or double dashes is going to become positive. So 5 minus negative 15 is going to equal 20. And 6 minus negative 6, again, that double dash is going to be 10. So 20 over 10 is going to equal 2 over 1 or just 2. So our slope is going to be m. So with that in mind, I can choose either point to use to write my equation in point slope form. Been a long day, so I was having a brain fart there for a second. So let's go ahead and we're going to first write it with the first point and then the second point. So remember, we want to follow along with y minus y1 equals m times x minus x1. And then we may need to clean it up. So of course, I forgot to put a line here. Bring this down. So what does that look like? So y minus, lowercase, y minus, and then I'm going to use this first point, 4, 5, and the y from that is 5. So y minus 5 equals m, we just determined our m is 2, parenthesis, and then x minus the x value, and the x value here is 4. Keeps, of course, capitalizing y, and I'm going to make it a smaller y. So this is an example of once we find that slope of us being able to write the equation using the first point. But, you know, what if you didn't want to use the first point, you wanted to use the second point? What is that going to look like? Well, it's still going to be the same format, except when we go to the second point, our y is negative 15. And our x is negative 6. And of course, because we're mathematicians, we're going to want to simplify that. And we're going to want to make it so that a double dash is changed into a positive or an addition sign. So we're going to make that y plus 15 equals 2 times x plus 6. And this is really important to keep in mind because if we were giving something in point slope form, when you're extracting the point from it, you know that you have to take the opposite. So if I'm given y minus 5 equals 2 times x minus 4, and I'm told to graph that, I'm not going to graph the point negative 4 and negative 5. I'm going to graph the point 4, 5, and then use the slope of 2 to find other points. So when we extract the coordinates out, we in essence have to take their opposite sign. So if they're negative or subtracting in the equation, they become positive on the outside. And if they're adding, then they would become negative. So if I was given the equation y plus 15 equals 2 times x plus 6, I'd extract the point negative 6, negative 15. So that's really important to remember about what the formula is versus how you may have to write your answer when it's cleaned up. But either way, that is point slope form. So that's kind of like just the first part of it, us understanding how to write point slope form, given the tools we already have. Of course, if they give us the slope and a point, we're not going to have to really do any work to write point slope other than substitute values in. Here we actually found the slope. But what happens if we use that as a mean to get back to slope-intercept form, right? Because while an estimate could be made of the y-intercept when using the point-slope form to graph an equation, in mathematics, precision is preferred. Precision meaning we want to be exact. So, for example, if we were graphing using point-slope form, we may or may not be able to know exactly where the y-intercept is, which is an important feature of a linear equation. So in mathematics, precision is preferred. So one way to determine the exact y-intercept from an equation in point-slope form is to convert the equation into slope-intercept form. So in order to do that, it's kind of like almost like a chessboard, right? This is an equation and we have to be able to move things from one side to the other to be able to get back to that formula of y equals mx plus b. So the way we're going to do that is we're going to use those 5 steps for solving equations to achieve this goal. So we should remember the 5 steps for equations. We should remember the hand signals. But we'll practice that in class. But if you're just listening to the video, you should know it's distribute, combine, rewind, solve, and check. That's not going away. Solving equations is like forever. So example. Use the information to write an equation in point-slope form, then convert it to slope-intercept form. So here they've given us a point and they've given us a slope. So we're going to go and do point-slope form first. So we should know that point-slope, right? We should practice this out, y minus y. To get to that sub, we hit control period 1, control comma to undo it, equals m parenthesis x minus x control, hold down the control, comma 1, do it to undo it, and a parenthesis. Okay, so that's point slope formula. I'm going to put a little colon there instead of an equal sign. So using our information, let's plug in or substitute in what we know. So we don't know the general y. That's always going to be there. Kind of like how the y and the x is in slope-intercept form. So y minus, based on this, our value for y is 10. So y minus 10 equals, they've given us a slope of 3, so m is 3. We don't know the general x minus the x1 is 2. So y minus 10 equals 3 times x minus 2. So we want to get back to slope-intercept form, which is y equals mx plus b. So we're going to go ahead and using our 5 steps, step 1 is distribute. We're going to distribute that 3. So now we know y minus 10 equals 3x minus 2. Okay. Now again, y equals mx plus b, so we have the y, and over on the same side with it, bugging it, is minusing 10. So how do we undo subtraction? Or how do we undo a negative 10? Hopefully we know the inverse of that is adding 10 or a positive 10 that we're going to have to put on both sides. Now, in this case, there are fixed numbers on both sides. That may not always be the case, but y, negative 10 plus positive 10 is 0, equals, I still have a 3x, and negative 2 plus positive 10 is positive 8. Right, so this is me getting back to slope-intercept form. Okay, so that's what you're going to do. So practice problems on page 68, I'm going to go back out so we can see the full page. Write an equation in point slope form to represent the information given. So I didn't actually make you find the slope on any of these. I pretty much just gave you the slope and a point, and you have to write it. And when I say write it, I want it in clean form, meaning no double dashes should be left in your final written equation. GP35 asks you to drag and drop the numbers from the middle, so 1, 1, 2, negative 2, 3, negative 3, into the equations to rewrite each equation into slope-intercept form. So you're given the point slope, and you have to do what we just did and convert it back to slope-intercept form. And so what is that going to look like? And that is point slope form and its uses.